This is my poster for primary production, and the abstract for this is temperature, sunlight, nutrients, and geography. All of these factors contribute to primary production, and the concentrations of chlorophyll A were measured at 3 sea arrays located in the Western Hemisphere in various locations. Chlorophyll A, what is it? Algae, a key component species upon which life depends, makes up chlorophyll A. And in the Erminger Sea array and the Station Papa array, there were higher levels of primary production. And these are in the Northern Hemisphere, while the southern location, the Southern Ocean array, produced much less. Levels vary from location to location based on nutrients brought in by ocean currents and glacial ice melt. And the oceanic primary production obviously forms the base of marine food webs, but also produces about half of the oxygen that we breathe in terrestrial systems. For the discussion, December to March shows little productivity, and this is due to lower temperatures and less sunlight, and this gives less for photosynthesis during colder months. Chlorophyll A levels rise between March and July as due from warmer temperatures and increased availability of sunlight for photosynthesis. A relationship between primary production and geography does exist, and this is shown in the Northern Hemisphere, where primary production levels are higher than at the Southern Ocean array. Upwelling currents occur near coastlines due to the Coriolis effect and where warm and freezing waters meet and mix. These higher levels of chlorophyll A are due to currents that create more upwelling in the northern locations. With heavily populated coastal areas, it can have immense impact on the composition of seawater and, in result, primary production. Like with excess nutrients can enter the water through glacial melt, nutrients can also enter the water from agricultural runoff or pollution caused by human activities. These can cause algae blooms to occur at odd times or greater amounts, and like fishing also impacts these algae levels, and this is caused from the less fish to eat the algae. The algae has more time to grow in dense amounts, and it remains longer in the ocean. If the primary production continues to become unbalanced, how would this affect climate change? What would primary production look like in areas that experience polar nights and midnight suns? Upwelling. Ocean waters are constantly in motion, from surface currents on an ocean scale to density-driven vertical turnovers into small rotating eddies, and this was said by Webb in Chapter 9 of 2019. And the movement of surface currents play a role in the vertical movements of deeper water, and this mixes the upper water column. This movement brings deeper water to the surface, and the major significance is that it brings nutrient-rich deep water to the nutrient-deprived surface. And this stimulates primary production. And I have a diagram here with the upwelling movement and what is brought in from the currents. I show the results of the near polar table from chlorophyll in the different stations. And the results were chlorophyll A varied throughout each array station. Although present, they showed very different levels of productivity, and these ranged seasonally by the availability of light and nutrients and the mixing of water during thermocline. The Station Papa array in the North Pacific had year-round levels of chlorophyll A that hovered between 0 to 5, and through March and April, it has shown a small increase in levels presented between 5 to 10. March through October, levels were slightly higher than the rest of the year. And with the Erminger Sea array in the North Atlantic, they experienced low levels of chlorophyll A throughout most of the year. In December to May, the levels were 0. Once May through July came, the levels at Erminger experienced a spike, reaching 23 near the beginning of June. Yet by July the levels had gone down to 0. In a small spike near the middle of July, and levels reached closer to 5. So for the remainder of the year, levels remained slightly above 0, and in August there is indication of an algae bloom, or maybe even technological issues, with a brief level of 25. So that is my poster. Sorry, I'm fixing my camera here. And my references down below were Webb, Chapter 5 through 7, 2019, was where I got most of my research through this week. And the upwelling chart was found on NOAA. And then the primary production, I found some research also on NOAA, which was very useful for this. And that's basically what I came up with for primary production.